So today we're going to talk about the roles and organizational roles and responsibilities associated with DevOps and how they're changing over time. So if you look at the responsibilities, regardless of what your organization structure is, you have some that happen before any coding. Uh, uh, so pre-production, I'm calling that. You have tool installation, tool configuration, maintenance of the tool. Which tools are you using? You have the testing configuration. You have the preparation of test case. You've done design. In particular, you've designed for deployment. You've designed for supporting monitoring. You've designed in terms of error messages and so on. Those are some of the design decisions that you make to support the operations process. You then you move into a deployment. Who gets to approve the deployment? Is this done by developers or by a special organization? But regardless of how it's done, there has to be an approval process, maybe implicit. Uh, then there's the installation and rollback of new releases. So once the deployment's been approved, it actually has to get installed. Once it gets installed, there's at least a potential that there's a problem, in which case you have rollback. Once you're in production, you have to do some monitoring. So there's monitoring, configuration, and analysis. There's incident response, what happens when something goes wrong. There's resource allocation. These are all responsibilities that have to get allocated regardless of your organizational structure. And depending on your organizational structure, they'll get allocated in different ways. So traditionally, the development or the development/production group was divided into three parts, and these may be different departments or they may be even different companies. So there's the development team. They're in charge of configuring the tool, in charge of developing test cases for integration. They're in charge of the design, so they design, deployment, and monitoring. You have a quality control group. They're in charge of the test cases when the system gets to staging. They're in charge of deployment approval. And then you have the operations group. They're in charge of actually maintaining and configuring the tools, the installation and rollback of new releases, the monitoring, configuration, and the analysis of the monitoring, the incident response, and resource allegations. Again, this is the traditional organizational structure. We'll talk now about how that's changing under DevOps. So how much it's changing depends on the domain of the organization. If you're looking at internet types organization, Amazon, Google, Netflix, they're the ones that have been showing the lead in doing this. Firms with internet-facing elements, such as financial or sales or banking, well, banking is financial, and they're adopting some of these practices and investigating others. And so they are, among other things, regulated. And so what they're able to do depends partially on the regulatory climate. So let's look at tool management. If you're a Netflix or a Google, you have a separate department whose responsibility it is to create new tools. In Google, this department is decentralized, so it could belong to people that develop new tools could have various organizational titles. In Netflix, it's exactly a department. Other organizations will allow developers to choose a tool suite. Still other organizations, operations chooses the tool suite, and we're talking about the tools in the deployment pipeline. And once the tools have been chosen, then the development team configures the tools for their own use. So just some terminology. There's something called continuous deployment. So continuous deployment means that's automatic deployment after the developer commits. So as a developer, you commit some code to your version control system. As we said, it goes through integration, build, it goes through staging, and then it gets deployed. And in those various states, there's automatic testing. And so presumably it doesn't get deployed unless it passes the testing criteria. That may not be all tests pass, but there is a set of criteria that determine it, and it doesn't touch human hands after the developer pushes the commit button. Then there's something a little bit weaker called continuous development. In this case, you have automated testing, but the actual deployment decision is manual. And so there's someone who may have to sign off on deployment decisions. And so what that means is that it's automatic to get it ready to deploy, but the actual deployment and pushing the button is manual. And that's called continuous development as opposed to continuous deployment. The rollback decision is either made automatically based on some rules or by developers. So when something goes wrong, then either the system decides to roll back by itself or developers decide to roll back. We'll talk about rollback more later. System-wide monitoring is done by the operations group, and they're looking at capacity of the network to handle the various types of activities. They're looking for signs of an intruder, and they're looking for hardware failures of various kinds. Application-specific monitor is done by the development team. And when something goes wrong, then that's an incident. So an incident can be customer complains about something, performance is unusually slow, there's a functional problem that's discovered, and how this is handled is very organizational dependent. So in some organizations, developers now carry pagers, and when something goes wrong, they are the first responders. In other organizations, the operations are still the first responder. In both of those cases, if you decide it's not your problem or you decide that the problem is wider than you can handle, then there are additional resources that you can call, either other developers or the operations people can call the developers or whatever. There's also, in Google, there's a separate team that's devoted to reliability, and they're the first responders. So they have a role called the site reliability engineer. And if you should look at the video in the readings in the syllabus, because one of the video is of Dan Klein, who used to be a site reliability engineer for Google. Resource allocation these days is almost universally under the control of the developers, and this is because of the cloud and virtualization. It's very easy to now allocate a new computer, virtual computer. You do that by sending particular commands to Amazon. But this leads to a different type of charging model. Back in the old days when organizations used to own their own computers, you as a development group might have your own computers and you could use them at your will. Production computers were under the charge of the operations group in your organization, and so typically there was not a charge for use. There was some scheme for arranging for financing to buy new computers. These days you rent a computer, you don't buy it, and you rent it by allocating a virtual machine, and so you charge based on the resources you use. And this is a different type of charging model. Actually, it's a throwback type of charging model. That's the type of charging model that used to be in play when I started programming, which was back in the 60s. The testing is more and more automated. If you're going to have continuous deployment, then it has to be totally automated, because there's not enough time for testers to actually perform their tests, let alone get up to speed with the kinds of changes that have been made. But in general, there's movement toward more and more automated testing as a way of speeding up the deployment process. So to summarize, many responsibilities, organizational responsibilities, are moving from the operations group and quality control groups to the development teams. And the developers are becoming responsible for deployment rollback, for certain types of monitoring, in some cases certain types of incident handling, for resource allocation, and for testing and test generation.